Welcome to section 5.4. We're doing sum and difference formulas. These formulas you're not going to have to remember. We're going to give you a sheet of paper at the end of this chapter with the formulas on it, but you do need to know how to use it. You will also want your unit circle today as we're going through this section, so keep that in mind. I'm going to slide this down just a little bit. Take a look. Okay, the first thing, what we're asking you to do is called the sum of two angles. So we're asking you to take the sine of the addition of angles u and v. And the way to do that is we take the sine of u times the cosine of v plus the cosine of u times the sine of v. Okay, so the formula in order to find the sum of these two angles and then take the sine is the sine of u times the cosine of v plus the cosine of u times the sine of v. If it's a subtraction of the two angles, same idea, we're just going to subtract this. The sine of u times the cosine of v minus the cosine of u times the sine of v. So sines ones are pretty easy. If you're adding them, you put a plus sign between it. If you're subtracting, you put a minus sign between. Cosine's the opposite. The cosine, when you add the two angles together, looks like this. The cosine of u times the cosine of v, and it's the opposite sign. So minus the sine of u times the sine of v. And so the cosine of the difference is the cosine of u times the cosine of v plus the sine of u times the sine of v. And again, it's opposite of what's there. The tangent is a fraction. Again, these are all in your book, but we're just giving them to you real quick. In the numerator, the tangent of u plus the tangent of v. In the denominator, 1 minus the tangent of u times the tangent of v. And when you subtract them, similar idea, only in the numerator you subtract. So the tangent of u minus the tangent of v, all over 1 plus the tangent of u times the tangent of v. So these are the formulas we're going to be using. Again, you need these formulas, which we'll give to you on the test, and then you also need your unit circle. And so we're asking you to find exact values. And so I look at my angle 75 and I say, is there a way to make my angle either an addition or a subtraction of two different angles that are on my unit circle? Well, the easiest way is to add 30 plus 45, because then the 30 plus the 45 gets you the 75. And now you can see I'm taking the sine of a sum, and so I'm going to use the sine sum formula. So I go above and I just basically plug in my angles. So I say, okay, the sine of 30 times the cosine of 45. Sine is a plus, so you put plus the cosine of 30 times the sine of 45. Okay, and we use our exact trig values. So we go to the unit circle and we say, all right, well, the sine of 30 is 1/2. The cosine of 45 is the square root of 2 over 2, plus the cosine at 30 is the square root of 3 over 2, and the sine of 45 is the square root of 2 over 2. While multiplying fractions, you multiply on top, so the square root of 2 over, and then multiplying the denominator is 4, plus multiplying square roots, you just multiply their numbers, so the square root of 6 over 4. And now I have a common denominator, so I add them together. The square root of 2 plus the square root of 6 all over 4. And this is my final answer. The goal of this section is really to be able to use your unit circle and exact values to find other angles on the circle that aren't actually part of those special right triangles. So there's the first one. Second one is cosine of pi over 12. Now, if you're not sure what pi over 12 is as a radian, you could take pi over 12 and multiply by 180 over pi, and what you'll find is this is 15 degrees. All right, so how do you get 15 degrees? Using my 30, 60, 90, or 45, 45, 90, things like that. Well, to get 15 degrees, I know that I could take 45 and subtract 30. But because this is in radians, we're going to stay in radians. So I'm going to take the cosine, and 45 is pi over 4, minus 30 degrees is pi over 6. Okay, and so in this case, I'm going to use the subtraction of it. So let's take a look. Okay, my cosine formula says if I'm going to subtract, I take the cosine of the first one times the cosine of the second one, and I'm going to add the sine of the first one times the sine of the second one. So I plug in my angles into my formula. And then I say, okay, what is the cosine of pi over 4? Well, that's the square root of 2 over 2. The cosine of pi over 6, which is 30 degrees, is the square root of 3 over 2. The sine of pi over 4 is the square root of 2 over 2. The sine of pi over 6 is 1/2. You end up multiplying like we did before, square root of 6 over 4 plus square root of 2 over 4. You get the square root of 6 plus the square root of 2 all over 4. And what you'll notice, hopefully, is these are exactly the same answers. And so the question is, why is the sine of 75 equal to the cosine of 15? And the reason is these are cofunction identities. Okay, the cofunction identities. Cofunction is definitely a word you need to know. Cofunction identity says the sine of pi over 2 minus an angle is the same thing as the cosine of that angle. And we went through these in the first section in chapter 5, and we haven't done a whole lot with them. We will today, and those cofunction identities are definitely something you need to know, both in name and in look. Okay, so let's move on, do a couple of more. We want you to prove this cofunction identity, and this is kind of the identity we just went through. So can we prove it using the sums and differences? Well, absolutely, because I know a formula for this. And my goal is to show that with the formula, I get this answer. Okay, so here we go. I'm going to do the cosine of pi over 2 minus an angle. The cosine formula says take the cosine of the first times the cosine of the second plus, because it's a minus, the sine of the first times the sine of the second. All right, so let's take a look. The cosine at pi over 2 is 0. The sine at pi over 2 is 1. 0 times anything cancels. What do you get? The sine of your angle. And so that's why those cofunction identities actually do work. They come down to sum and difference formulas. And we don't want to have to write this every single time for our cofunction identities, and that's why they give this cofunction identity. Because again, we don't have to write these. We don't want to have to write these sum and difference formulas every single time to be able to use them. All right, number 4 says come up with an identity for the tangent of, and this is a parentheses theta plus 3 pi. So we're going to use the sum for a tangent, and our goal is to be able to then write an identity when we're done. So theta plus 3 pi, let's stick it into our tangent formula. So our tangent formula says add the two tangents together and divide by 1 minus their product. Okay, now let's talk about 3 pi. As I look at my circle, here's 1 pi, 2 pi, here's 3 pi. And this coordinate point is -1, 0. So what is the tangent at 3 pi? The tangent at 3 pi is sine over cosine. 0 over negative 1 then is 0. So I'm going to put that into my function. The tangent of theta plus 0 over 1 minus the tangent of theta times 0. Well, anything times 0 goes away. So in my numerator, I have a tangent. In my denominator, I just have 1. So let's write our identity. The tangent of an angle plus 3 pi is exactly the same thing as the tangent of the original angle. And you've just created your own identity by using these sum and difference formulas. All right, let's keep going. On the back, I really love the question at the top because it mixes in 5-3 and 5-4 together. So it's using the sum and difference plus, you're having to solve the answer once you're done. So this is absolutely, these two questions on the back are two of my favorite questions, which means you will most likely see them again. Take a look though. We're going to use the sum and difference for this first one. And according to our sum and difference properties, we take the sine of x times the cosine of that angle. And it's a plus, so plus the cosine of x times the sine of that angle. And so there's the first one. Plus, let's do the second one. The sine of x times the cosine of pi over 4 minus the cosine of x times the sine of pi over 4. This all will equal negative 1 then. Now you can go at this a couple of different ways. I'm going to just get rid of the pi over 4s because I know I can find those exact values. Like the cosine of pi over 4 is the square root of 2 over 2 times the sine of x plus the square root of 2 over 2 times the cosine of x plus the square root of 2 over 2 times the sine of x minus the square root of 2 over 2 times the cosine of x equals negative 1. And by doing this, what I can see then automatically is I have a positive and a negative cosine, which will cancel out. What I'm left with then is 2 of these square root of 2 over 2 times the sine of x. Now, as I go through, these 2's will cancel out. So I have the square root of 2 times the sine of x equals negative 1. And let's just start solving. If I divide by the square root of 2, then the sine of x is, let me rationalize this a second, negative square root of 2 over 2. And so we go to our unit circle and we say, okay, which quadrants is the sign going to be negative? Well, this is going to occur in quadrants 3 and 4. So they're 45-degree multiples because of the square root of 2 over 2. So my x has to equal 5 pi over 4. And the period of sine is 2 pi, so plus 2 pi n. And my other solution is 7 pi over 4 plus 2 pi n, because that's in the fourth quadrant. So what I love about this is it not only does section 5-4 with these sum and difference formulas, but it also includes 5-3 where you're having to find on the unit circle all of these possible solutions. And they use the word general solution, which is why I knew I had to include the 2 pi n's. If they would have said from, they normally put it this way, from 0 to 2 pi not including, they normally write it like this. If they write it like this, then I would just say x equals 5 pi over 4 and 7 pi over 4, and you wouldn't need the 2 pi n's. But because they say general, you also have to include them. Okay, last one. I also love this one because it mixes in part of 5-3 or actually chapter 4, which we haven't done in a bit, but I love this question. Take a look. I'm going to do the cosine of a sum, okay? So here we go. The cosine of my sum says take the cosine of the first times the cosine of the second, and it was a plus, so it's minus the sine of the first times the sine of the second. Now, in chapter 4, we talked about the fact that what happens if these are the same trig values or if they're different trig values. So if they are different, like let's start with the first one, they're different, this inside piece helps us make a triangle. So here's what I'm going to do. I'm going to put some triangles over here on the side. And I've got my first one, and we're talking about the arctangent of 1. So if I write this as a fraction, it's 1 over 1. Opposite over adjacent. And if I do Pythagorean theorem, 1 squared plus 1 squared equals the hypotenuse squared. So 2 equals the hypotenuse squared. So the hypotenuse is the square root of 2. And so this is the arctangent of 1. So I can cross this off and just say, let's look at the cosine of theta for this triangle. And we'll work on doing that in just a minute. In this second one, cosine and arccosine are inverses, so those cancel. You get times x minus, oh, I've already done the arctan triangle, so this basically cancels out and I can look at the sine of theta. The problem is these two are different and I don't yet have a triangle for the arccosine. So let's make a triangle for the arccosine. Let's not call this theta actually, let's call this something else. How about alpha, so we don't get our two angles mixed up. Cosine is adjacent over hypotenuse, so the adjacent side is x, the hypotenuse is 1. Again, according to Pythagorean theorem, you could say x squared plus the other side squared equals 1 squared. This is very similar to a quiz question and a homework question we had. B squared is 1 minus x squared, so you square root. This is the square root of 1 minus x squared. So when I look at this triangle, I can take this triangle gave me my alpha triangle, so I have times the sine of alpha. Okay, so now we just start filling in the blank. Now that we've made a triangle and we've simplified it at least down to 1 trig value each, we can start writing things out. So take a look at my theta triangle. The first thing says find the cosine. So the cosine is 1 over the square root of 2 times x. We'll simplify that in a second. Right now I just want to get them down. The second one says take sine of my theta triangle, so opposite over hypotenuse, 1 over the square root of 2, times the sine of my alpha triangle. Sine is opposite over hypotenuse, so the square root of 1 minus x squared. Now we've got some simplifying to do. And actually, I'm going to make this as easy as I can. I'm going to go x over the square root of 2 minus the square root of 1 minus x squared over the square root of 2. Common denominator says x minus this square root all over the square root of 2. And we never leave a square root in the denominator, but truthfully we will make more math mistakes if we don't just leave it there. So in this case, I'm okay with us leaving it here. Okay, you could try rationalizing, and it might be easier to rationalize when you're back here. But truthfully, in my opinion right now, if you can get here, I'm okay with that. So that's section 5.4. Take a second. You want to practice some of these questions before you get to class. But those sum and difference formulas I will give to you.